So, if you're a builder in the AI space, you know the struggle, right? Adapting these huge, powerful models is just incredibly expensive. But what if there was a way to customize them for just a tiny fraction of the cost? Well, today, that's exactly what we're digging into, a powerful set of techniques that makes it happen.
Lightweight fine-tuning that fits your budget. I mean, this sentence just nails it. It perfectly captures the promise of what we're talking about today. And honestly, this isn't just some small improvement. It's a total game changer. It makes powerful AI accessible to anyone with a great idea, not just the folks with super deep pockets.
Okay, so before we dive into the solution, let's really set the stage. We need to get a clear picture of the problem that pretty much every developer and company is running up against. Just try to imagine a model with billions, or heck, even hundreds of billions of parameters. To do a full fine-tune, retrain it on your own data, that takes a colossal amount of computing power, a ton of time, and so much money. It's a massive barrier to entry, and it ends up locking out so many brilliant projects just because they can't afford the server bill.
But what if you didn't have to retrain the whole thing? This is where our hero comes into the story, parameter efficient fine-tuning, or as you'll hear it called, PEFT.
Here's the magic trick. Instead of messing with all billion-plus parameters, PFT methods are smart. They target a teeny, tiny fraction. We're talking often less than 1%. You freeze the original massive model, and you only train these few new parameters. The result? You get incredible performance on your new tasks without those crippling costs. It's all about working smarter, not harder.
Now, PFT isn't just one single technique. It's more like a whole toolbox full of brilliant methods. We're going to take a tour of 3 of the most popular and, frankly, most powerful methods that builders are using right now.
First up, we've got QLoRa. Yeah, the name might sound a little complex, but the idea behind it is so clever. It basically attacks the problem from 2 different angles at the same time. First, it shrinks the original model to save a bunch of memory, and then it trains these small, separate modules to handle your new task.
So let's break that down. First, you quantize the model. It's just a fancy way of saying you reduce its precision, which shrinks its size dramatically. Think of it like saving a super high-res photo as a smaller, more efficient JPEG. Then you freeze that smaller model so it can't be changed. And finally, you slot in these tiny, trainable layers called adapters. It's a brilliant way to get new skills while using just a fraction of the memory.
That whole idea of adding small trainable modules is really central to our next method, which is simply known as adapters. And honestly, the best way to think about these is as literal plug-in modules for your AI model. Now, what's so cool here is how simple it is. You take your massive pre-trained model and you just lock it down completely. Then you strategically slide these little adapter layers in between the model's original layers. The only thing you end up training is these new plugins. It's kind of like adding a new feature to a piece of software without ever touching the original source code. Okay, our third technique, prefix tuning, takes a completely different path. It's less about changing the model and more about becoming an expert at talking to it. The key idea here is creating what you could call a learned prompt. With prefix tuning, again, the core model is completely untouched. It's frozen solid. Instead of changing the model's parameters, you train a small, virtual prefix that gets tacked on to every input you give it. This prefix acts like a perfect little set of instructions, telling the model exactly what to focus on to get you the right output. You're not changing the engine, you're just giving it a world-class driver. All right, let's just pause and look at this, because this table is perfect for summing up everything we've just covered. You can see these 3 really distinct approaches right next to each other. QLoRa, it's all about smart compression. Adapters, they're like modular plugins. And prefix tuning, that's all about crafting the perfect learned prompts. Seeing them laid out like this makes it super clear how each one gets its efficiency in its own unique way.
So, we've gone through the theory, but theory is only useful if we can actually apply it. And that brings us to the most important question for any builder out there.
This is it. This is the key takeaway, right? It's not about which method is objectively the best, but about which one is the best fit for your specific goals, your constraints, and the resources you have to work with. There are really 2 crucial things to think about. First, there's that trade-off between control and resources. Some methods might give you more fine-grained control over how the model behaves, but maybe at a slightly higher cost. Second is flexibility, and this is where a method like adapters just shines. You can have one giant base model and then train dozens of tiny, specialized adapters for different tasks, like one for summarizing articles, one for writing code, one for creative writing, and you can just swap them in and out whenever you need. It is incredibly efficient.
All right, let's bring this all home and talk about the big picture. Why does any of this matter so much for the future of how AI gets built?
And this is the main conclusion. For the huge majority of real-world applications, the massive cost and complexity of a full fine-tune is it's overkill. PEFT methods can give you comparable and sometimes even better performance at a tiny, tiny fraction of the cost. This whole shift is basically democratizing AI development. So, I'll leave you with this final thought to chew on. We know these AI models are only going to get bigger and more complex. So, is it possible that these efficient, parameter-saving techniques won't just be an option, but the only practical way forward for anyone outside of a few giant corporations to innovate and build the next big thing in AI? It's definitely something to think about. Thanks for tuning in.